Hey guys, and welcome back for a bit more game development. I know we've spent quite a bit of time on this cargo crane feature, and I'm quite anxious to get onto other things, but we're going to be spending a little more time on this feature because it's quite complicated to implement, and it's a very central piece of the means gameplay concept. So, I wanted to give you a sort of a status update on what's been going on. So, in accordance with my new plan for the video series, I'm going to be developing more things off screen rather than doing everything on video. In an attempt to hopefully give you guys a bit more interesting content from one episode to the next. And I have spent quite a few days now working on this crane, and I wanted to give you something like a status update on what's been going on. So in this video we're not going to necessarily develop all that much, but I want to show you what I have, the current state of things. So at a first glance this might seem pretty similar to what we had in the previous part. So you have this thing that we can move around in the local space of the vehicle. We can lift it up into the air, and if we drive the vehicle around, the thing follows along with it. So that's all cool. But I've actually fixed quite a few things since last time. So first of all, the joints no longer sort of glitch when you actually pick something up, which means that you can pick up very small things, not just these large vehicles, things like that. I also use something called joint projection to make the overall chain of objects on the physics side more stable, so you can just mess around with these much more without the physics sort of breaking completely. There's still some work on that front to be done, because you can still break this if you really want to. Like trying to pick up another mother vehicle, for example, will surely break the cable. But overall it's getting very solid. So once I had that working better, I started working on something that actually turned out to be quite a tricky problem. So let's do something like this. Let's take a picture of this again, just to sort of rehash the idea. The idea, if you remember, of the crane was to have like the base of the crane somewhere around here. Let's actually make this a bit thicker, something like this. Drawing with the mouse again, so awesome art. You would have some crane arm like this, and then some other piece of the crane arm like this, maybe even a third piece of the crane arm like this. And so actually this thing that we're moving around here, this guy, is actually sort of the end of the crane arm. And so with some simple inverse kinematics we can actually pose this arm to follow this point, as long as it is within the range of the vehicle, so to speak. And then from the end of the arm onwards, so I hate it when paint zooms to the top left corner. I should really use a better image program for this. From the end of the arm onwards, we have this cable here, so like a steel cable essentially, which you can see here, is actually modeled using the physics engine, and works quite well. And at the end of that we have the magnet that attaches to things that we can pick up. And the plan has always been that the length of this cable is variable. You can make it shorter or longer within certain limits, of course. And I had a few ideas for how to do that sort of thing. I had one version where you have essentially like sort of like a ring or an eye, if you will, a body like this, and this thing would follow along with the end of the arm, and you would lift it up, and it would sort of pass through this, and that was how you would actually make it longer or shorter. That didn't really work out. So my other plan, and the one that I currently have implemented, works like this. If we want to make the cable longer, we simply add more segments to the end of it. And you can see the end of the arm sort of jumping up and down. So you can still move the thing up and down like this, just like you used to be able to do before. But if you retract or extend the cable, what we're essentially doing is we're moving the end of the arm upwards until we reach a point where we can simply remove a segment. And then we do that, and we jump back down, and we attach to the next segment. And this seems to be the version of this which works best. There are some issues with this still, especially on the visual side, where you can clearly see parts of the cable sort of getting a little nudged when a segment is removed or added. But this actually works quite well, and you can of course sort of combine moving the end of the arm with actually extending or retracting the cable as well. And it works quite well. Remains to be seen if this is the actual final version of the variable length cable, but I think it might be. So this took quite a long time to do, and once I had that, I started thinking about, okay, how do we actually in the end, how do we render this thing? Because of course I want this crane to work in a networked fashion as well. You're supposed to be able to play parts of means in co-op, or at least that is my hope. And so what you're seeing currently, these physics representations, these are actually what we have on the server. So server physics shapes, you can toggle them on and off, and you can see the physics as it exists on the server. Well, normally in a multiplayer environment, you can't really draw things that are on the server. First of all, they might be on another machine, but even if they are not on another machine, they might be actually running on a different thread. So, like best practice in a client server situation is to just not try to render the things that are on the server, even though you can sort of do it in like a development context. And so I started thinking about, okay, well, I have this chain modeled on the server, and I want to actually render it on the client. Like, how would we do that? And one way would be to just simulate it on the client as well, but it might get kind of tricky to actually get it to line up completely with what we have on the server. We do actually simulate physics on the client as well, and that is, for example, how we can clearly see that the model of this vehicle, which is rendered by the client, like if you turn that off, everything you see here is now rendered by the client. And you can clearly see that the vehicle is moving along. Like if we now shorten this, you can see that the vehicle is moving along, and that is done simply by synchronizing the transforms of the vehicle, the one on the client with the one on the server, or rather the other way around. The one on the server gets synchronized with the one on the client. But this chain is simulated only on the server. So how do we actually see this chain now moving around as the yellow line on the client as well? And that turned out to be quite tricky to do for a number of reasons. First of all, like the most obvious thing that you could try to do is just simply send the information over the network to the client. And we can do this if we take a look at the chain. The chain is now, I think it is at its maximum length. No, actually it wasn't, but we can make it. So now we have it at its maximum length. The maximum length is currently 30 meters. So that means 60 of these small segments, these capsules here. Because a capsule's height is half world unit, and so 30 meters means 60 segments. Well, let's do the math real quick here. Let's take Python. So, right, we have a float. A float is 4 bytes, right? If it's a float, 32. So then we have a vector, a 3D vector, is then 3 times the float. So that would be 12, right? So one of the positions or a position for one of these guys would then be 12 bytes. So then you take vector times 60, and you get 720 bytes. So that's almost 1 kilobyte for the whole chain to serialize over the network. And every time we make an update, we would actually have to send the whole thing again. So that clearly doesn't really work, at least over like an unreliable internet connection. So I tried all kinds of things. I tried analyzing the chain. Like if you have a look here, let's go closer to this part here. You have this chain following this sort of the shape of the vehicle here, but then you have like this very, very straight part. So I tried doing all kinds of things where I would actually send all of these things, and then I would detect that this is actually very straight, and it would only serialize this, and then it would serialize this as the next one until it actually started making like a curved shape again. And that kind of worked, and it brought down the data amount quite a bit, depending, of course, if the actual chain is straight or not. But it also introduced all kinds of visual glitches, which I wasn't really happy with. So that wasn't going to work, and I figured that if I actually want to make this chain look really nice in the game, if I want to do something like this, where I move it very close to the body of the vehicle, like this, and then I start sort of almost like winding it around. Oh, it's difficult to see without any any shadows of where this chain actually is. But if you do something like this, you bring it very close to the vehicle, and then you start actually sort of winding it over the edge. You can see that it intersects a little bit with the vehicle, and you can clearly see that, okay, that the segments are sort of being pushed over it, and there's a little bit of glitching there, but it's not actually that much. It does look reasonably nice. And so if I want to do something like this, where I actually want to tie it around something else, I do sort of have to send all of these guys along so that the client can then recreate the visuals without it glitching all that much. And so I had to somehow compress the data a little bit, because I wasn't going to be able to send 720 bytes every time I wanted to send or update the cable on the client. So what I ended up doing was this. Let's quickly shut this down. I'm going to uncomment this. There's one line here. We're still in C++, by the way. I have some things that I need to expose to Zig, but the final version will be in Zig once I know how I actually want to implement this. So let's actually do something like this. I'm gonna want to make this. I'm gonna want to move this chain quite a bit, and then I want to pause it. So what we do here is we calculate the bounds of of the chain in world units. And if I unpause it, you can see that it updates the axis aligned bounding box all the time. And so it follows and encloses this part of the chain that is visible. And when we know that, we can actually send just the axis aligned bounding box over the network. And that would be 6 vectors. Oh, sorry, 6 floats actually, 2 vectors. So a minimum and a maximum vector. So not that much. And when we know that this is the only part of the scene where we actually have any chain visible, we can then lower the precision of each point along this chain within this bounding box. Like, we don't need to store all of these points with full precision, and we can lower it quite a bit because we know it's never going to go outside this this bounding box. And what I ended up doing was storing them rather than as 3 floats. I ended up storing the points as a 32-bit unsigned integer. And so with 32 bits, you can have something like 11 bits for x, 10 bits for y, and 11 bits for z, right? So now if we do x plus y plus z, you get 32. So we can store in an 11-bit number. We can store numbers between 0 to 2048, or actually 2047, because 0 is the first one. So 2048 different positions from here to here along the x-axis, like this. I selected y as the component with 10 bits. And with 10 bits, you only get to 2023. So from up here to here, you only get 2023. And the reason I chose the y-axis is that most of the time, the cable would just go sort of straight down. And so it doesn't really matter. You can't really see any visual changes if you just move a cable that goes straight down, upwards or downwards. And then for the C, the same actual 11 bits. And you can fit all of these into 32 bits, which means that suddenly we just got rid of essentially 2/3 of the data. So let's see how I did. If we just bring this up, make it as short as it can be. So now we have only we have 1 meter of cable, or 1 world unit, if you will. And we have 2 segments. So you can see network stats. We have incoming data per second, and this is now on the client. So the server sends currently almost 8 kilobytes per second to the client. And now if we start making it longer, we can see the rate going up, but it's not that bad. Let's make it as long as we can currently. It should be 30 meters when it is at its longest, and I'm not sure that is really necessary. I'm not sure we really need to make it and allow it to be that long in the game. But now we can see that it's quite long, and we are up to 21. So it was almost 8, and we're almost at 22. So that means that that we are sending essentially 14 kilobytes per second of chain data, and this is with essentially the worst case scenario where we have the longest chain imaginable. with this reduced accuracy? Well, I think it looks quite nice. Obviously, we're still doing, this is just like debug drawing, and I can imagine this yellow line not being super visible in a YouTube video, but I hope you can see that it flows quite nicely with just 14 kilobytes. So if we derive that, let's do 14k is this, and we divide that by 60. You can see that we're sending a little less than 240 bytes rather than 700 and something. So our math checks out. It's just a third of the raw data. So that's kind of nice. I think we might be able to send this data across the network. And of course, most of the time it's going to be significantly less, because having a cable this long, while it might be kind of interesting, is not really the most sort of efficient way, perhaps, of using this crane. Here you can see that when I am extending or retracting this cable, you can see the cable sort of, you can see the movements of adding and removing segments to it. It's kind of visible in the cable. It's obviously visible in the bounds, because the bounds are sort of jumping up and down. But there's a little bit of movement there that I probably have to sort of fake it somehow on the renderer side to make it look like it's sort of spooling it smoothly up and down a little bit, especially in the beginning of the cable. So anyway, that is basically where we are at. Actually, let's get something more tricky to lift. Let's get a truck number 2, and we can just move this up, and we can retract the cable a little bit, and we can move it somewhere above this guy, and lift it, and I will demonstrate that this actually works quite well even with these heavier vehicles. So I kind of like the idea that, or kind of like the visual look of this. Like now, if we remove this, would perhaps be even nicer without the bounding box. But oh well. We'll connect this, and you can see there's no glitching anymore. Nothing glitches, and we can just very nicely lift this up and move it around, and we can even lift it by retracting these cable pieces. So I think this should make for a pretty nice crane experience. So I think the next thing for me is going to be the actual crane arm. There's some interesting challenges there. For example, if you remember the previous crane that I showed you, the so-called attractor crane, which is not really physically driven, didn't have any collisions for the crane arm. So I'm thinking I might have to actually do that to make this crane feel sort of sensible and realistic. And yeah, you can still definitely make this mother vehicle fall over by lifting these things. So that's one thing, doing the actual arm, and that of course will put some physical constraints on how you can actually move this thing around. Like now you can clearly like move it like a kilometer from the vehicle if you want to. But the arm will it will rotate around its base, and the movement will be completely different. And so that should be really interesting, and it should sort of tie together the vehicle and the actual thing that you're lifting in a much more sort of tangible, sensible way. So that should be fun. Expect an update showing that real soon. Perhaps even next episode. And yeah, I think that is it for today. This part turned out to be, like I said, mostly a showcase of what I've been doing. This is not how all of the upcoming episodes are going to work. We're gonna develop things on video, but it wasn't what I wanted to do today. So that's why we went with this format. And I think I'm also gonna start actually adding some subtitles to these videos so that you can more easily find an episode that covers a certain thing if you're interested in finding out about it later on. So I don't know what the subtitle of this video is gonna be yet, but you know because you clicked on it. So lucky you. Anyway, with that, I thank you for your time. I hope to see you in the next part. Take care, and